Hi everybody, welcome back to session 2 of our Women in Statistics and Data Science in Aotearoa, New Zealand. I'm going to be starting off the session with my talk, which is titled Biostatistician, the Perfect Job I Never Knew Existed. So I've always been quite interested in how, well, I've actually thought it was really cool how we have such a diverse group of people that work as biostatisticians, and my kind of path to get where I am has not been a direct path. It's actually been super indirect, but I feel like my journey has helps me to explain or highlight why I think being a biostatistician is a perfect job for me. So way back yonder, when I came to university, I didn't really have an idea of exactly what I wanted to do. I ended up trying out quite a few different things. So I did chemistry and anthropology, psychology, statistics, and law, having no real idea that one of them was going to be my main course. Getting into second year, I pretty much decided that psychology was weird for me, and chemistry had 8 o'clock labs in the morning that didn't suit my lifestyle at that time. So I continued. Eventually, I ended up completing a BA with a major in anthropology and a minor in statistics. And part of that was because I just really enjoyed anthropology. I like to hear about people and culture, and statistics was mainly because I did pretty well with not much work, which is pretty sad, but I really did enjoy stats. And so after this, I ended up going to Auckland, because when you're from Dunedin, like I mentioned before, Dunedin has a population of about 130,000, and you kind of want to go to the big smoke. And for us, the big smoke is Auckland, which has I think it has over 1 million people, which is small in the big grand scheme of the world. But for us in New Zealand, Auckland is the biggest city. So I went up to Auckland, lived there for 5 years, and while I was there, I decided I wanted to come back to university. So I got back in touch with Otago University, so David Fletcher and John Haraway, who were really important in my career. And so we kind of made a plan of attack together, what I needed to do if I wanted to come back and do a postgraduate diploma in applied statistics. So I took a couple of maths papers up in Auckland. Then I came back 2008, and as part of 2009, I changed and I started a Master of Science in Statistics, and then that was changed and it became a PhD in Public Health. And during that 2009 year, when I was looking into doing a Master's, is when I got involved I took a longitudinal paper, and that's when I first actually honestly became aware that there was such a thing as a biostatistician. I didn't really know anything about this area, even though I was in statistics. And so I did my PhD, which was looking at employment in school children and its association with substance use late in adulthood and psychological well-being. And during my PhD, I really realized that biostatistics was a perfect merge of my interests and skill set. And so it really aligned with this job. And then it also, when I did my PhD, it included the two public health papers, which just made me realize or appreciate that this is where I wanted to be. So I was really lucky that I had a postdoc kind of customized for me, and it was a year postdoc, and the primary purpose of which was to build experience in the role of a consultant statistician within this division of health sciences. So it involved 4 projects, and they were really different, which just really further reinforced that I really would love this job. So it had one of them was using Munsell soil colour charts to describe skin colour. I'll talk about that later on. And then I did one called about kahungunu, infant safe sleep, the KISS study, and that involved, there's a picture up there on the right of a wahakura, and that's an Indigenous safe bed or safe sleeping device. And that project involved comparing outcomes between the control bassinet, which a lot of people use, and the wahakura. And then another of those projects looked at tobacco smoking among New Zealand adolescents, and it involved investigating the influence of media culture and consumer culture on youth smoking, and involves structural equation modeling. So for someone who's just out of statistics, that was quite intense. And then I did a qualitative research project with Claire, who's talked today as well, and that was I mostly looked into the literature review about professional challenges, and we ended up publishing an article on challenges for professional statisticians. Today I'm just going to talk about one of my projects, which was the validity and reliability of the Munsell soil colour charts for assessing human skin colour. So I don't know if you can tell me if you can see this clear. So this is the chart. Can anyone know? This is the real chart. So this is what that is used. So background to this project is that skin colour is a key factor for ultraviolet radiation exposure-related cancers. And so you need acceptable, valid and reliable measures of skin colour. If you rely on methods of self-report, there's a bias towards overestimating your skin colour in terms of darkness, which obviously the corresponding to that would be that you potentially underestimate your skin vulnerability to UVR exposure. And although there are like really sophisticated technologies available, like always have trouble with this word, spectrophotometry and other such technologies, they have their practical limitations. Like for one thing, they're quite expensive. They require external power sources. So depending where you're going, when you're needing to measure people's colour, and they can be somewhat invasive. So this project was all about trying to test the reliability and validity of the Munsell soil colour charts, which I showed up to you before. But it's actually on. So this is the book that's a revised washable edition. It's a three-dimensional expression based around the concepts of hue, value and chroma. Hue describes the relation of a colour to red, yellow, green, blue and purple. Value indicates lightness and chroma indicates strength. So there's 9 sheets in this book, and it was originally designed for geological purposes to help with classifying soils. But in the book, it also says that it can be used for the evaluation of skin, hair and eye colour in anthropology, criminology, pathology and forensic medicine. So it was an opportunity to see if something else could be used that was a bit more practical and less invasive. So the project involved coming back so it was 2 different times. A person would come and they'd do a proper spectrophotometer measure, and then they'd also have two people using the Munsell charts looking at their skin colour, and there was a primary rater and a secondary rater. So we were able to, and then they come back in 7 days and do the primary and secondary rater again. So that gave us the opportunity to look at both inter-rater and intra-rater reliability and also validity, comparing the Munsell classification to the actual spectrophotometer measure as well. So the measures for both the Munsell chip and the spectrophotometer are both converted to an ITA, an individual topology angle. And so this can range from -100 to 100, and 100% equals pure white and complete reflectance, and -100% represents pure black and no reflectance. And then from the ITA, it can also be, it has a corresponding skin color as well. So on that graph on the right, you can see it goes very light, intermediate, tan, brown, and dark. The analysis involved looking at, for reliability, we looked at the ICC And we also did the weighted kappa, so 2 different ways of testing the reliability. And validity, we looked at the mean difference or the bias, and we looked at the limits of agreement. And we also used the weighted kappa. So I had never, before coming across this project, I had never looked at an ICC before or a kappa. So one of the really cool things about my postdoc was you're introduced to what being a biostatistician really is. It's, you know, a job is way different to your studies. And I think the studies give you the skills, the basis, and then you have to learn a whole lot of different stuff on top of that. So it was quite overwhelming having to learn about ICC and kappa and then structural equation modeling, because I felt like I was drowning a bit in stuff that I'd never learned. But I've also realized that's a part of my job, is I'm just learning new stuff all the time, and that is actually just fine, and it's actually really cool. So we did, these were our statistical analyses. Now results were that the when I go back, the 0.7 was considered acceptable for an ICC, and for a kappa, 0.6 was considered. So those were the cutoffs for what was essentially what a good and what was bad. And the inter-rater reliability for both of them was good, and the test retest, they were both acceptable as well, which was good, because it pretty much said that the Munsell was a good, was both valid and reliable. We had our bias though, and you can definitely see that the average bias was about negative 0.09, but it could be as high as 26 or as low as 26.71 negative 26.71, and which showed that even though it was reliable and it was valid using those statistical methods, if you look at the plot, it also shows that it suggests that although it could be those things, you need to have some caution, because if you can see down the bottom here, there seems to be a consistent pattern where the primary rater overestimates the darker skin type. So obviously these should be on this line, and they're lower on those negative values. That's all my actual talk about how I got to where I am. I just what I wanted to highlight was the difference, how heterogeneous biostatistics is, and all the different cool projects I had for a first when you were young and just coming out of studying. What do I love about statistics? My probably premium thing is that being a biostatistician is the perfect combo of my interests and skills. And that's, I think, what everyone wants to find in a career. You spend a lot of time at work, and you know, you want to be doing something that you enjoy as well as are good at, hopefully good at. I really enjoy collaboration. I just enjoy chatting to people. I like learning about new things, and I also love having such a central role in research, which has the potential to hopefully positively impact society. And then, thank you. How do I get out of here?
Now,
Ella, that was a really interesting talk. I wonder, it's not a very statistical question, but how do people feel about having their skin colour measured in that way? Do you have any sense of that?
Well, I wasn't involved in that, but I think it helps that it's like you can see the kind of chart. So it's kind of probably interesting for the person looking as well. So I don't think most of the times that you're looking for skin colour seems to be that when you're involved in cancer research, or where actually where it's really important. So you're doing it for a reason, and I think that reason is legit, and people can understand why you're putting skin colour into a model, whereas other things that may not be moral or ethical at all.
Interesting, isn't it, that there was an existing soil chart for colour, but no one had thought to develop one, that the skin one wasn't developed first, possibly. I don't know.
I think there is a skin one. Well, there are skin ones, but they're in like the cosmetics industries, and they don't want to share, because I think when I was talking to the other people involved in the research, they had approached, like, I don't know if it was L'Oreal or whoever it was, and they definitely have some kind of skin charts, but it's painted or whatever. They didn't want to share that knowledge.
Oh, fascinating.
I thought it's just interesting because it's so different. My projects, the 4 projects I did, were just so different, and I thought it's quite what's so cool about it. Well, yeah. Well, part of the thing I like about my job is how it's all so different, so it's not boring.
And I think it's more of a comment than a question, but I think that it was fantastic, the postdoc opportunity that you were given, and both in terms of, I guess, giving you a taste for what a job as a career as a biostatistician would be or could be like, and also a chance to develop your skills in a supported environment. We probably need to figure out ways, I don't know, to make more postdoc positions like that available into the future.
Yeah, I forgot to say that each of those projects had like a main supervisor. Yeah, that's
fire
us.
alarm.
We're going to have to
stop recording.
Hi. So 2 of our presenters had to leave the building because there was a fire alarm, but I will start my presentation. So Kira Tato, ko Yangyang Te Monga, ko Nakdong Te Awa no Korea Oho, ko Kim Toku Anao, ko Alice Toku Ingoa. Kira, everyone. Thank you for the opportunity to present at the session for celebrating women statisticians and data scientists in New Zealand. I'm based at University of Otago, Wellington in Te Whanganui Atara, Wellington. And I grew up in Tamaki Mokoro in Auckland. But like many of us in New Zealand, I was born elsewhere in South Korea. And something that I'm very proud of about my adopted home, New Zealand, is that we were the first self-governing nation to grant women the right to vote. And of course, globally, there's a lot to be done in terms of equality among all genders. But we have a pretty good track record when it comes to women leadership, with both our Prime Minister and Governor General being women. So now to our main agenda. Statistics and data science for me are special because they provide ways to connect with people, learn about their story, understand how things are, and learn from the past and look ahead. And a lot of people consider statistics and data science to involve just numbers, but it's incredible what insight they can share with us. And as health scientists, we often work on populations who are at high risk of ill health. And for me, that involved working with data on children and babies who are at high risk of developmental difficulties. So I'll share 2 examples in this presentation. One of the longitudinal cohort studies I had the privilege to work with involved children who were born with very low birth weight. So these were babies with birth weight less than 1.5 kilograms or with gestational age of 7 to 8 months. And most of these babies spend their first couple of months of their lives in intensive care units undergoing extensive medical treatments. And the last trimester of pregnancy is quite important for the development of major organs such as heart and lung. And most of these babies miss that period in their mother's womb, where a lot of these are co-regulated between mother and the baby. So the long-term development of these babies is of interest to pediatricians, and there's still very high inequity in outcomes for these populations across the globe, with the majority of them surviving to discharge in countries like New Zealand, where we have neonatal intensive care unit facilities, whereas almost all of them will not survive in other countries without such healthcare. And so in this study, we analyzed the executive functioning skills at 23 years or young adulthood. Executive functions are skills that are important for learning, decision-making, planning, and emotion regulation, and are highly correlated with socioeconomic outcomes. And here we compare the executive function outcomes between adults born very low birth weight and adults born full term or with normal birth weight. And these plots show 3 composite scores for executive function skills. And higher scores indicate greater difficulty with executive function skills. And the blue line indicates the outcomes for the very low birth weight cohort, and the dotted green line is for the full-term cohort. And the red dotted line is the clinical cutoff, indicating indicating the executive function impairment. So it was heartening to learn that most adults born very low birth weight do quite as well as the full-term cohort in executive function in adulthood. However, when we look at those children, those adults above the clinical cutoff, we see that a higher proportion of very low birth weight adults still struggle with executive function compared to the full-term cohort. And we also found that these skills were related to their socioeconomic outcomes, such as occupation and home ownership. So this highlights the importance of long-term follow-up studies, as a lot of children born very preterm or very low birth weight transition from neonatal intensive care unit to usual healthcare settings. And there's still a lot to be learned about their long-term outcomes. Another study I was fortunate enough to be involved in was the longitudinal study of children who were exposed to opioids during pregnancy. Now, opioid epidemic is, of course, a very topical issue worldwide, and children born to pregnant people with opioid use disorder and who experience neonatal opioid withdrawal symptoms is a growing population. Methadone and buprenorphine are synthetic opioids that are used in maintenance program for pregnant people with opioid use disorder. And they have higher half-life, so the longer half-life, so the effect is more stable than other opiates. However, it's very much a harm reduction strategy rather than a harm elimination treatment. And the dependence on these synthetic opioids and prescription opioids is a growing problem worldwide. So here in this study, we analyzed children's brain volume at birth and the average exposure to methadone, a standard treatment used in opioid maintenance program during pregnancy in New Zealand. And we see that a smaller brain tissue volume is observed among children who were exposed to higher dose of methadone. And when we look at each trimester, we see that the effect is stronger in later trimesters. And this makes clinical sense as the brain develops more rapidly during the last trimester. So this study is based on a small sample of about 30 children for whom we had high quality MRI data available. However, it's still important because we don't have much information about safe dose or timing of administering these drugs. So the evidence from these cohort studies is quite important. And these children were some of the most resilient cohort whose data I've come across in my work. And in other studies, we've seen how important high quality early childhood education and parenting is in mitigating some of these difficulties in their development. So I want to end my presentation by briefly introducing 2 of my statistical heroes who inspired me and generations of other statisticians and data scientists in New Zealand. Late Professor Alistair Scott was a great supporter of women statisticians and data scientists, and I was fortunate to learn statistical theory in his course. Associate Professor Ross Ihaka is, of course, well known for co-creating R, statistical programming language. He's also a staunch supporter of his colleagues of all gender and a proud son of Ngāti Kahungunu and Rangitane tribes of Wairarapa. So thank you, Alistair and Ross, for taking interest in my interest in statistics. And thank you, and please feel free to email me at this address if you have any questions regarding the studies I shared today.
Thanks, Alice. That was really interesting. I liked how you had the mix of, I guess, talking about your background, some of your heroes, but also those are two quite powerful research studies that you were involved with as well. Yeah, no, I found it really interesting. Thank you. In terms of the brain volume at birth, do you know of any, for the opioid study, is that something, and this is a non-statistical question, but has anyone looked at compared brain volume sort of at 3 months or 6 months to see whether those differences in brain volume that you observed at birth either increase or decrease between the levels of exposure groups?
Yeah, that's a very good question. And for our particular data set, which is, of course, thanks to Professor Lee and Woodward at Canterbury University, we don't have that data set. We've only had MRI data at birth. And it was very difficult to get high quality MRI data because the babies are quite irritable and they move around a lot. So the actual cohort is bigger than 30, so they're about 200, but we were able to only get 30 high quality MRI data. But there could be other data sets elsewhere that might have that information I'm not aware of. However, typically this is extremely hard to reach high risk population, and our cohort of 100 exposure group is actually one of the best in the world. So I'll be quite doubtful whether they have that much information. Maybe more recent studies might, yeah.
And you bring up sort of that tension between what the ideal is in terms of what you want to know and how you want to conduct the study with the what's feasible both in terms of the population, in terms of costs, in terms of the data collection tools. Yeah. Challenges. Thank you. But like you said, amazing that you were able to do what you were able to do.
Yeah, I thanks also, Alice. That was a very interesting talk. And I have a question which I don't know if you'll be able to answer because you may not have had the data, but I wonder from other studies you may have read. So it was quite pleasing to see that the executive function for the very low birth weight versus full term for adults is comparable. But is there any information on when, at what age people start to catch up? Because I imagine that at young ages, there might be differences. But at what ages do the very low birth weight people start to catch up in terms of executive function?
Yeah, so for different outcomes, it might be different for executive function. And it's also based on the follow-up periods, at what age we follow them up. And it's usually critical age of development. And so most studies show similar outcomes by young adulthood. Although there is overall challenges in terms of developmental outcomes as they age. So there is still physical health sequelae and both mental health and physical health sequelae. But in terms of executive functioning, international studies and our studies show that on average, they perform on par in early adulthood. But of course, we see that there's a proportion of them who still struggle. And one of the limitations of a lot of these studies is that the most at-risk cohort are excluded from the study. So those who suffer from severe impairment, cerebral palsy would be typically not included in the study, which I think is a pity because we are not looking at the people who are at highest risk. But however, that's the case currently. Yeah. For most of the existing studies, longitudinal studies, are looking at people who are performing quite well, or who don't have the most severe impairment.
Yeah, that's fascinating. Is there any reason why those people more at risk are excluded, or is that just the standard practice?
I think at the beginning it might be, well, I think there are a couple of reasons. One is that the most severely impaired, or even those who didn't survive, were excluded. And because of the health issues, they wouldn't be able to complete the assessment, which could be a day or 2 days in length. Another is that they would have considered them as different population. But yeah, so.
Okay. All right, thank you. Okay, thanks everyone for sticking with us this far. And as you can see, our two colleagues are back from the fire alarm. Fortunately, it wasn't such a huge incident, and we're glad to have them back. So I thought I would share with you in this session my journey from where I was born and up to where I am now, and my work as a statistician. So I'm currently a senior lecturer in statistics at the School of Mathematics and Statistics at Victoria University in Wellington. And the picture that I have there is a picture of Wellington on a good day, which can be very beautiful on a good day, but not so much on a windy day. And my name is Noktava, by the way. So where did my journey start? My journey into statistics started in Zimbabwe, which is where I was born and obtained my first degree. Zimbabwe is a landlocked country in Southern Africa, and we share a border to the south with South Africa, as well as a number of other countries. The population currently is 14.86 million, so not a very small country. An interesting tidbit of information for you. Our most well-known feature is the Victoria Falls, which we share with Zambia on the northwest border, and it's known as the largest sheet of falling water in the world. So that's Zimbabwe, which is where my journey started. And as I said, I obtained my first degree there, which was a BSc Honours in Statistics at the University of Zimbabwe. That was in 1994. I then went on to obtain an MSc in Statistics at University College London, and then a PhD in Statistics at Imperial College London. So much as it might look like I really knew my path and I really knew where I was headed, that's not true. When I finished high school, I really didn't want anything to do with statistics. I didn't like it from what I learned at high school, but I love maths. And then so at the University of Zimbabwe, I enrolled in a BSc in mathematics. And fortunately for me, even though at the time it didn't look fortunate, our first year was such that you had to take a range of papers in mathematics, statistics, chemistry, and physics. And of course, one of those papers was statistics. And somehow I went from avoiding statistics like the plague to really loving it through that first year paper. And from there, I got hooked into statistics, and I've continued ever since. And one of the things I really love about statistics is how you can take a complex data set and turn it into stories, or reveal the stories that underlie that data set, and really get some great insights. So after obtaining my PhD in statistics, I then, as I was finishing off my PhD, I worked as a biostatistician for about 5 years. This was for an organization called UK Transplant at the time, but it's now called NHS Blood and Transplant. And my work really involved survival analysis related to organ transplants. I then decided, well, maybe working as a biostatistician in an organization wasn't it for me. So I thought, maybe let me try an academic environment and see what it's like. So I got a job as a research fellow jointly with the London School of Hygiene and Tropical Medicine and the Royal College of Surgeons, where my role was mainly research, but also supervision of students. And then a year later, we decided as a family to move from the UK to New Zealand. And that's when I joined Victoria as a consulting statistician, and then moved into an academic role in 2009. So my path, while it's all been in statistics, it's been varied with different roles. And that has allowed me to build a picture of what I really am interested in. And I think ultimately for me, the academic role I have suits me quite well. So other roles that I have, in addition to teaching and research in my role, currently I have a number of administrative roles. The Secretary of the New Zealand Stats Association, as I said in session 1. I'm also Associate Dean of Postgraduate Research in the Faculty of Engineering, which means I have oversight of all research students within the faculty. Earlier this year, I served as a co-ambassador for Women in Data Science, and this for me is a quite nice continuation of that role of promoting women in data science or statistics. Those two fields are quite well intertwined. So what do I enjoy about my role? I love teaching, which I think is why the academic role suits me quite fine. And what I enjoy about that is making statistics accessible to students of various backgrounds. Increasingly, we're teaching students who want to be data scientists, and quite often they come in with backgrounds that are not the traditional statistics background. And so you have to take those concepts, statistical concepts, and make them accessible to those students. And that's one thing I really enjoy. Also enjoy working with research students and helping them develop from being a student into a researcher. In terms of research, I have the privilege to be able to choose sort of different directions or be involved in lots of different projects. And so my research kind of is in two branches. I have applied research, which tends to be multidisciplinary and really collaborative. And this tends to be driven more by the people or the group that I'm researching with. And then I have a theoretical aspect, which is driven more by my own curiosity in terms of what am I interested in and what do I want to explore. And so I've got two examples here that cover both of those. So the first one, this is an example of an applied research project, which really, where I played a role really more as a biostatistician. So this was work with the National Centre for Women's Health Research based here at Victoria. And we were investigating whether HPV self-screening would improve the uptake of cervical screening amongst women. And the particular concern there was that our indigenous group, Maori, tend to be underscreened or they never really screen. And so the hope was that if you make HPV self-screening accessible, which tends to be more acceptable to them, then it might increase the uptake of screening. And this is the result that we found, that among Maori women, the use of self-screening actually increased the uptake of screening almost threefold. And the reason for this is because cervical screening, the current smear test tends to be quite intrusive, and for some women, it's not a comfortable experience. Whereas self-screening is something that's easy that they can take home and do by themselves. And this really did improve the uptake of screening. And so my role in this was really just helping design the trial and also analyzing the data. And we published that in 2020. The other project is now more a theoretical one, which is more sort of curiosity driven, so my own interest. And this one is about in the area of modeling disease progression and I'm specifically interested in cancer progression. And this is a project I'm doing with a PhD student that I'm supervising. The background to this is that New Zealand, amongst other countries as well, are currently considering introducing a national screening program for lung cancer. The challenge with screening programs like that is that it's hard to test their effectiveness using a clinical trial. It's very expensive and time consuming. And so if you can develop simulation models that you can use to evaluate how these trials might work in a population, then it's worthwhile. So the research we're looking at is to build a simulation model that we can use to evaluate what introducing lung cancer screening might look like in terms of the effectiveness of reducing lung cancer mortality, but also looking at cost effectiveness as well, or that's a sort of a much larger project outside of PhD. So the way the simulation model works is that you take your disease progression and divide it into different stages. The first stage is when we have onset of the first cancerous cell, and you have a model for that. So you use a hazard function to determine the time at which the onset of malignancy might occur. And then you track, once that first tumor is formed, then you track the disease through growth of the tumor to different stages: local state, which means it's still, say, for example, it's lung cancer still within the lungs. And then regional state is when it's moved into the nodes, say, lymph nodes, say, and then distant state is when it has metastasized into the body. And then at any point along that that timeline, a patient may die due to other causes or may die due to lung cancer. And so we have models, statistical models that we use to model that process. And then the question is, if we were to introduce screening, what would be the reduction in mortality rates be like? And that's where what we're looking at the moment. An initial result from that study is where we've taken our simulation model and simulated it according to the New Zealand population. And we've then compared the incidence rates we get from the simulated population to the incidence rates that we see in the real population. And we're quite pleased to see that our simulation model gives us really comparable results in terms of incidence rates. And what that means is that it then forms a very good baseline that we can say, okay, if we introduce screening to this virtual population, then what would the effectiveness be of the screening in terms of reducing mortality or indeed cost effectiveness. So these are initial results that we've written up in a paper and submitted quite recently. And one of the developments in that was to introduce a new way of calibrating simulation models using a Bayesian approach. And so that for my PhD student, that was quite a good development. So those are the sort of examples of the two projects that I've worked on. In terms of my other research, so I tend to be involved in a lot of applied projects because that's what I enjoy most. I enjoy working in fields where, or in areas where my work has real application. And so what you find is that my work will involve health research, and so fitting in quite well with the rest of the speakers in terms of biostatistics focus. But I've also been involved in work in fisheries modeling, for example, working with people from NIWA, and that has led to a number of PhD projects, as well as a postdoctoral project. So yeah, that's sort of it in terms of my journey into statistics and the work that I'm doing. And I will just on this next slide, I've got some emails with contact details, but before I show that, I think I will stop for some questions in case anyone has questions.
Thank you, Noktaba. That was very good presentation. I have a question about the simulation model.
Yeah.
So the screening usually brings forth the detection, the time of detection. So is that what you took into account in modeling?
Yes. So when in our first model, we just simulated the progression of the disease without any intervention. And we looked at what the mortality rates are under that situation. And then when you introduce screening, the idea then is that you detect the cancer earlier before it has a chance to progress, maybe to spread and metastasize. And then what that means is that if you intervene early, then you increase you reduce the mortality rate. So that's the purpose of, yeah.
Hi, Noktaba. That was really interesting. Thank you. And a good opportunity to get to know you better and the type of work that you're involved in. As we mentioned earlier, Noktaba's in Wellington and at a different university from the rest of us presenting here. I was just wondering if you knew whether Professor Sue Kringle knew about your paper, or if you when it's published, you should share it with her, because she's got some funding from HRC to do a trial on lung cancer screening.
Yeah, I haven't been in touch with her, but is that the work that's looking at focusing on Maori?
Well, it's Māori-led, but looking at different,
yeah.
Looking at whether the screening reduces the difference in survival rates between Māori and non-Māori.
Yeah, yeah. Yeah, no, thanks for that suggestion, Gabrielle. I hadn't made contact with her, but definitely would be keen.
Let me know if you want me to, I know, introduce or anything, because I work with Sue on a few projects.
Yeah, no, that would be great. That would be awesome. Thank you.
I have a quick question, Noktaba. Thank you for that. I was wondering, since you had your education all in Zimbabwe and now you're teaching in New Zealand at a university, are they similar kind of teaching like practices, or is it so different in New Zealand from how you're trained in Zimbabwe?
That's a very interesting question then. It has a very long answer. It is different, but I'm not sure if the difference is because it's a different area, a different country. So education in New Zealand in Zimbabwe rather, is based on the British system. So when we were growing up, we used to do Cambridge exams. So our education system was very similar to what we see in the UK. And what that meant is, for me, for example, we'll do a whole paper on just regression analysis, if I'm thinking of the statistics education. But what I've found here in New Zealand is that teaching tends to be more, not so much in depth, but we cover a lot of topics in one paper. And that has an implication, I think, on the level of understanding that I feel students live with. But it's also, I think, a reflection on the demands of perhaps employers these days, that people want someone who can apply or analyze data, and not necessarily someone who knows the theory and can prove a theorem. And so the differences are there, but I think they're a reflection of a change of the times more than anything. Yeah, but otherwise the teaching, it's all taught in English and very similar customs, except I had to get used to people calling me by my first name. In Zimbabwe, you don't call an adult by their first name. You refer to a teacher, say, by their surname with a title. So that was one cultural difference that I found.
That would drive me insane, because my last name would be horribly pronounced. So I'm very glad I'm in New Zealand then.
Yeah.
Thank you.
Okay. I think there aren't any more questions. So if there aren't any more questions, I'll share my screen back and share our contact details, but also then just give just a brief closing talk. Okay, so you heard from a number of speakers today, and some of us included our email addresses in our talks. Some of us didn't. I know I didn't personally. But if you have any questions on any of what you heard today, please feel free to reach out to any of us. The email address is available there for you to see. Or if you can't remember, you can just email you can email one of us and then we'll direct you to the right person. And so a final word. So this is just a final word to thank the people who organized this particular session, and that's Claire really led this from the BioStats Center, and I was sort of invited to take part as an NZSA representative. And I would like to thank everyone else who spoke from the BioStats Center, Otago, and also Alice from Wellington. I really enjoyed all the talks. It was really great to hear what you're all doing and to learn more about you, seeing as for some of us, this is our first interaction. And finally, this session is part of a whole day celebration to celebrate the International Day for Women in Statistics and Data Science. And this was organized by the Caucus for Women in Statistics, as well as the Portuguese Statistical Society. And I just wanted to give thanks for this brilliant initiative and hope that it continues for more years to come. Thank you so much.
Yes, thank you very much. It was great.
Thanks, everyone.
Thank you all.